Wow. Okay. The final broadcast of the International Spacecraft Exploration Challenge. Claire, we have made it to the end. How are you feeling?
I don't know what to feel. So many emotions.
Me
I'm
too.
still really excited. I don't know that I'll be able to sleep tonight, but it has been incredible. You
It
guys have been incredible.
I agree. I want to hear, how was your last day? How were those last missions? How are you guys feeling? I'm sad and happy. It's bittersweet. I mean, you guys did it. You did all the missions, you made it through spacecraft, all the lessons, all the tutorials, amazing guest speakers, which we have one more right here in a minute, which will be a great last one. Oh, I'm sad. I'm reading the comments. Maddie, I'm so happy you got pizza for lunch.
It's just the icing on the cake, right? Liam says, thanks for all this, space teams. Glad you've enjoyed it.
Yeah.
Everything was amazing. Awesome.
Had a great experience. I love it. Okay. So I have one final engagement question for our audience. And this is a theme that has been brought up through a lot of our speakers, which is following your passion, finding what you're passionate about and pursuing it and doing what it takes to get there and to kind of, whether it's space or even dancing or singing. And some of our mission experts have a wide range of interest and passions, like we heard at the earlier broadcast. I saw some of those come through in the Space Teams community, but I want to know, what are you guys passionate about? And perhaps this experience maybe brought some new passions that you didn't even know about. Claire, what are you passionate about?
Space exploration? Is that too cliche?
It's Space Teams, yes. It's a great, perfect answer. A+.
And I bet we all have that same one in mind, but it's okay to have more than one passion, right? What are you passionate about, Natasha?
I also love space. I love launching rockets, and I love playing music. I play the piano. I wish I could beatbox like Waylon from earlier. I cannot. Ooh, astrophysics.
Or the environment. Legos.
Ooh.
Love that. Neil wants to plant the first tree on Mars.
I love that.
Very specific passion.
It is. It's a goal.
Yeah. Lego astrophysics. That must be a new genre.
Ooh, our seaplanes.
Acting and ideas. So you guys are very passionate about a lot of things, and I'm so excited that you are also passionate about things that we have covered in Space Teams. But in fact, you guys are so passionate that, as you know, you crashed. We crashed the servers today because of your enthusiasm and because you guys have been so amazing. So I think that's another important lesson that we all know, that especially in space exploration, whatever field you're going to go into, you're going to experience some sort of hurdles or failure, and we all can learn from them. And fortunately, we still have everybody's scores.
Yes.
So not to worry, we're still going to have an epic ending to this week with an award ceremony where all of your scores are in, and you will be surprised with who the winners are for each award. And hang tight too. If you want to go back and explore some of those missions further, you'll still be able to through the end of this weekend. So way to go, guys. Way to persevere. And so much so that we've had an epic end of crashing the entire thing. So
well awesome. Said. Okay, so now it is time for our guest speaker. Let me read a little bit about him before I bring him on. So, Dr. Ben Morrell is a robotics technologist at the NASA Jet Propulsion Laboratory, California Institute of Technology, working in autonomous navigation technology for robots flying, exploring underground, and in space. Ben is also working on autonomous approach to comets and asteroids, focusing on visual-based relative localization. Dr. Morrell has a bachelor's and a PhD from the University of Sydney. Let me bring him on. Hello, Ben. How are you doing? You will need to unmute your mic. I cannot. Perfect. How are you?
Doing great, and even better now that you can hear me.
Yes.
And very excited to be joining the Space Team's crew from this round. And it sounds like you guys have been doing some incredible things over this week. So I'm glad to come in and be a small part of it.
Well, we are very happy to have you, and I will let you go ahead and take the floor. You can start sharing your screen. I see that you unshared it, so you are going to need to reshare your screen. And so perfect. Okay. And so we'll be back as you talk. The students can ask questions. We also have those pre-submitted questions from earlier. So we'll see you in a bit.
Cool. Thank you. I hear that all of you have been working on a lot of things for your space missions and your space habitats. And one of those things has been using some robots to help you on your EVAs, some tele-operated robots that are helping you to explore and find resources to sustain your habitat. And what I want to talk to you about is some of the ways we currently use robots for exploration. And this is generally scientific exploration to learn more about the solar system and the universe. So this is one fairly famous example of a robotic explorer. This is a rover that goes around on the surface of a planet. In this case, it's a Mars rover on the surface of Mars. But there's other types of robotic explorers that may not look quite like your robots you might typically have. This is Cassini. That was a robot explorer going around Saturn and its moons. So it's an orbiting type of robot explorer. And we also have things going beyond the solar system, such as Voyager here. This is still going, this is just an artist's depiction of it here, but it's going beyond what we think of as the planets and the sun. This is more than 40 years old. That's been going away from Earth. And this is a bit of a picture of like a family tree you could think of missions sent from one of the NASA centers called JPL. It's a NASA center in Los Angeles. Every single line here is a different robot that's been sent out to explore different things, such as different planets, different asteroids or comets, or to do astronomy, looking beyond the solar system. You can see there's lots of green lines there to what I would argue is the most important planet, Earth. It's a pretty good one to learn more about so we can look after it, but also to all the other different planets that we have around the solar system. Now, this is a bit of just a snapshot of some of the planets, and I want to dive into one in particular, and that's Mars. It's kind of our nearest neighbor, the easiest one for us to get to in many ways. It's quite similar to Earth, but a lot smaller. However, if you look at Mars on the right-hand side, it is the surface of that sphere is the same area as the total land surface on Earth. So the total surface of all the continents on Earth, total area there, is the same as the total area on Mars, because Mars doesn't have an ocean. But it's also, because it's smaller, the gravity is less. It's about a third of what you would have on Earth. And also, it's not much atmosphere. You can see this nice line of atmosphere around Earth. We know we've got the air we breathe. It's about 1 to 10% of that on Mars. So a lot thinner atmosphere, less air around. So one of the things that we're really interested in for Mars is there life, or was there ever life on Mars? And now, we're not really looking for little green men necessarily, but looking for small forms of life, things that we call bacteria or microbes. But really, we can't go directly to answering that question when we send our explorers. We want to go towards what do we need for life to exist? This is kind of similar to what you were doing in your mission, where you're finding out what do I need for humans to keep living, to keep existing. Same things when we're looking for other signs of life. So some of the things that you've been looking for is water, really important for what we understand life needs. Also some type of energy. So you guys were looking for geothermal energy if you're going away from the sun, energy from the planet. But also if we're close enough to the sun, we can get solar energy as well. and some type of, I'll call it food. Food being some of the minerals, the nutrients you need to fuel life. You're looking for methane that is fueling your equipment, but this may be different types of minerals that are needed to build up what life is or feed whatever these small forms of life are. And we're looking for these on Mars. But the problem is we're on Earth as humans. And currently we don't have a good way to send humans to Mars. And so really that's why we use robotic explorers. So we want to find out answers to these questions about was there life on Mars? But to do that, we need to send the robot explorers. So here's a bit of a history of some of the landers that have gone to Mars. We have the Viking landers. This is the Phoenix lander that had a scoop to inspect it just under the surface. We had Pathfinder with a little rover there. You see something, a little rover with 6 wheels called Sojourner. And then we had the Mars Opportunity and Spirit rovers. And then Curiosity, a really large rover about the size of a small car. We had the InSight lander that had something that detected earthquakes or Mars quakes. And then very recently we had Ingenuity and Perseverance, which we'll get into a little bit later. So when we're looking for life on Mars, there's a few steps that we need to build up to, just like you have many elements that you need to support a habitat. So first of all, was there ever water on Mars? Is there currently any frozen water on Mars? Is there any liquid water on Mars? Because generally we need liquid water rather than just frozen water. Are there the ingredients that we need for life? Think of it like the food. Are there more complex ingredients that build up to life? And is there any current life or past life? One of those questions on the right-hand side we're not going to get into too much, and we still don't know in general around the world. But we'll talk about some of the earlier stages of how we use robotic explorers to find out more about it. So first of all, was there ever water on Mars? So here's one of the Mars rovers. This is either Spirit or Opportunity. And there's a few great observations this made by driving around on the surface of Mars. You can see it's got 2 cameras at the top that it can use to take pictures of the different types of geology that it observes. So this is the different types of rock formations and the different colors to look at the minerals that it is around it. So this is one where the fingerprint here is the geology. If you see these little ripples here through the rock, those ripples are indicative that there was once flowing water. Geologists back on Earth see these patterns in rocks and they know that they only form when there's been some type of stream, like a riverbed or a creek, that is causing those patterns on those rocks. So this says there was once flowing liquid water on Mars. We also see the mineral composition that tell us about the history of water on Mars. In this case, it was an unfortunate wheel that got stuck for one of the Mars rovers, and it dragged that wheel through the dirt. But when turning behind to look at what happened, it actually dug up some of that dirt and revealed this white material underneath, which is something called a silica, which we understand only forms in the presence of water. And so that suggests there was once liquid water on Mars. So from these evidence and a lot of other different observations, similarly, from driving on the surface, pretty confident that there was once water on Mars. Now, is there currently water on Mars? First of all, let's look at currently frozen water. So this is what the Phoenix lander was looking to do. It had a big robotic arm on it that you see there with a big scoop. And its goal was to dig under the surface and see, was there ice on Mars? Can you guess what it found? It found ice. It found water ice on Mars. Now the challenge is once it scooped and it revealed it, it very quickly turned to water gas and then escaped into the atmosphere. Because of the small atmosphere there, it doesn't stay as liquid form. But we found solid ice, solid water ice there under the surface, and very, very close under the surface, just with a scoop. So this was also confirmed and mapped for the whole region where water is by satellites that are going around Mars. They see things like this crater that's full of ice and different regions where there's a large concentration of this water ice. And they've even mapped out using both cameras but also other imagery of different spectra to work out what's the density of water, what's the distribution of water around Mars. This is like a map we might have of Earth, but for Mars, with these different colors indicating how deep we think water is under the surface. And so this is really interesting for potential future human habitats. If we want to extract water, we probably want it to be on this purple scale, where it's closer to the surface, which means it's easier to extract and use. And so this is where people are using this information to look at where would a good habitat be for humans when they were to go to Mars. Okay, so we're pretty certain there's water ice on Mars, and we've got a good distribution of where it may be to extract. But if we're looking for life, is there any current liquid water on Mars? Because that would be extremely interesting. So here we use cameras again and different robotic explorers. In this case, we're using a satellite robot explorer that's going around Mars. Now this takes images of different regions, and it can take the same images of the same region at different times, at different seasons. And so what it sees is in this region here, which is a cliff, it's on the edge of a cliff, he sees these weird black lines, and maybe that's just some type of rock formation, but these black lines change in different seasons, which is odd. Is there a Martian little green person coming up and drawing black lines? Probably not, but something changes from on the left in one season to on the right, we see a different black streak coming out here. And so what we think that is some type of liquid flowing water, but maybe a really salty water, something we call brine, that slowly melts as the season changes and it becomes slightly warmer and goes down. We don't know for sure though, because it's really hard to get close to that. It's on the edge of a cliff, so we can't drive a rover up to have a closer look. But if it is flowing water, that could be very interesting as a potential place where life could be. So still a question mark on is there any liquid water on Mars? But those slope features, we call them RSL, recurring slope lineae, which means lines that recur and change, basically. Okay, but we'll get back to that, but at the moment we don't know if there is liquid water on Mars. Now, next step is, are there the ingredients that we need for life? So these are the chemicals we need that build up what we know to be life. We look at a periodic table of elements. You may not have seen this. You may have seen it. It's kind of something you might be introduced to in high school. But there's some key components that make up life. Carbon, which is what a lot of what we're made up of. Nitrogen, oxygen, and phosphorus. You might also see on the top left is something called H. If you've been looking into water, it's H2O, hydrogen and oxygen. And we've got lots of hydrogen in the solar system and the universe in general. So we have some oxygen, then maybe we could have some water. But these other ingredients are important to build up what makes life. Oh, and sulfur, another one added on the end. But normally to look for these things, we need some type of microscope, some type of lab instrument to look at different rock samples and see what are the components there. But our rock samples are on Mars. So how are we going to get the rock samples to our instruments to see what it's made out of? Well, we could send Mars to Earth, but that's probably going to be pretty dangerous to have a planet coming to this planet. But what we do is we send our lab to Mars. And how do we do that? We send Curiosity. This is called Curiosity to most people, but also called the Mars Science Laboratory. MSL is the name it's called by NASA, inside NASA. And that's because it's a laboratory on wheels. It has a lot of instruments inside it that it can use to analyze the soil. It's still got cameras that it can take awesome images of and look at the geology, just like the smaller Mars rovers. But it also has a robotic arm with lots of instruments on it that can dig into the rock, take samples, and put it into its body where it has instruments that it can use to analyze it. This is really cool. But how do you choose where to go and drill a rock? How do you control it to go and drill in a rock, to go and take those samples? You need to be able to operate this complex laboratory on wheels to be able to actually make measurements that are interesting. So does anyone think we might joystick a robot on Mars, use a little Xbox controller to drive a robot around? You can look at the comments later on, but it's actually really hard to do that. Why? Because it takes 8 to 20 minutes for your signal to get from your controller to the rover on Mars. So it's like playing Mario Kart and you turn left, and 20 minutes later, your little Mario Kart turns left. It'd be very, very hard to drive. I'd definitely come last in Mario Kart. So we actually operate by sending instructions for each day. And we send those signals through something like this. This is big antennas that send signals to Mars and receive signals from Mars, as well as other places around the solar system. And this is actually in Australia for the Australian teams competing. This is just outside of Canberra, a place called Tippinbilla. It's a Deep Space Network, the DSN. There's one in Australia, there's one in California, and there's one in Spain, so we can look at different directions from Earth to make sure we have contact with all our spacecraft or our robots. The signals then come back to the processing center at JPL, the NASA center in California that's doing these robotic explorers. And those signals are sent to a team that analyzes them to choose what to do next. They'll get images like this, which are from 2 cameras that look at the rocks that are around. And they can use that to plan how they want to drive the rover. And they'll put that into a simulator, very similar to what you're using in spacecraft, though I think your spacecraft one's much cooler. And then they'll see, okay, if I send these commands for the next day, what's the rover going to do? And is it going to be okay over this terrain that I can see? The terrain images, or the terrain that they have modeled, is based on the images that the rover's taken in the previous day. And they test that out, they make sure it's okay, and they send up all those instructions for everything they want the rover to do for the next day. And you see all these images that are taken here to help them plan what they want to do. They collect all the images it's taken and build this VR model where the scientists can walk around in augmented reality to collaborate and work out, where do I want to go to get some more measurements? We're going to be sending instructions for the rover, but we need to choose, based on what images the rover's taken, which rock we want to go and take a sample of. And so they're using augmented reality or virtual reality to help collaborate, to make decisions on where to go next. And so through that process, they choose which rock they want the rover to go to, and through sending instructions for a day, the rover goes up, takes samples. And with these operations, we've been able to confirm that these important elements for life do exist on Mars. They found them in different rock samples, went through the lab on-site Curiosity, and it was able to confirm the existence of these elements on Mars. So we have a tick for the ingredients for life. Now, that's kind of the first building block. Next thing we want is something called organics, and these are the more complex building blocks. If you guys have heard of DNA, this is what makes up life that we have. And it's made up of these different, what we call bases, but basically lots of elements in them, lots of the building blocks that have been seen before. But the more complex things we see here, these hexagons, which each corner is a carbon element, they're called organics. So basically think of it like we've got the elements, and then building the elements together to something a bit more complicated is these organics, and then they eventually build up to something called DNA. So we're looking at that middle step of the more complex compounds. Do they exist? So one of the ways we advance that more quickly to find things that may be interesting to have organics is using a laser. This could be very scary to have a big robot with a laser on Mars. And I think if it was visiting my planet, I'd probably find that very scary. But we don't think, again, there's any little green men. But this laser, it vaporizes that rock and then analyzes the reflection from it to say what it's made out of. So from a distance, it can zap this rock to identify, oh, what's this rock made out of? And why is this useful? Well, we can make this autonomous. So as it drives along, it uses its cameras to detect all different types of rocks that may be interesting. It then can pick targets to autonomously zap. And so instead of just driving from A to B in one day, and then the scientists working out, okay, can you zap that rock, and that rock, it can autonomously zap the different rocks with a laser, do its drive while it's doing that, and then report back, not just I've driven, but I've driven and these rocks, 5 to 10 rocks are really interesting, but rock number 3 is super interesting. You should look into that in more detail. So I can use a laser to identify interesting areas to go and look in more detail. And so through this process, it found very interesting type of rocks near river formations, where it was able to drill in, take a sample of that rock, and then analyze it for organics. And it did. It found these organic compounds, which was very exciting to the team. And it suggests that there's really these building blocks for life, more so than just the elements, also the combination of elements. Now, we're not going to get into these two questions on the right because it's still an investigation. There's not really many more details to tell you. But what we're going to do is try and explore more with robots to help answer these questions. So let's just jump back to the liquid water one because they've still got a question mark there, which is worrying me. Remember those recurring slope lineae, those lines that were changing in different seasons? How can we confirm whether that is water or is something else going on that we don't understand? Ideally, we'd be able to get close to there, right, and go take some measurements. And so what we did recently, or what NASA did recently, was to land the latest Mars rover, the Perseverance rover. This is really exciting to watch. And if you haven't seen it, this might blow your mind. So this is coming to Mars. It deploys a parachute that helps to slow it down in the atmosphere. It's a thin atmosphere, but it still slows you down with a parachute. And then eventually, as it gets lowered down, it drops, let me go over here, it drops off the parachute, drops off a heat shield as well, and starts to descend, and it's using cameras facing down to track where it's moving. As it gets further down, you can see it's making out more detail, and eventually it drops off the parachute. And it goes into what's called propulsive mode, so it's got rockets that are firing to slow itself down. And again, it's tracking to see what's the environment around it, what's a good landing place, maybe I need to move to the side. And then as it gets closer, it does what's called a sky crane maneuver. So it starts to drop the rover down off from the rockets. So you see the ground on the right, the bottom left, you see the rover drop down, and then you see the rocket hanging above it, but hanging it on a crane, so we don't blow too much rocket exhaust on the rover. This is all real footage from Mars. Eventually, the rover hits the surface, and then the rocket detaches and flies away to a safe distance to make sure it doesn't damage the rover. And this is how we land a rover on Mars, and everyone's super excited. We just landed a massive car-sized rover on another planet. So while this is just super cool in and of itself, and I love watching that video, there's also a friend with a rover. Where did that come from? Does everyone see that? There's a little helicopter that came with the Perseverance rover. This is called Ingenuity. It was carrying a ride, just like a kangaroo might, on the belly of this Perseverance rover. It had a little shield to protect it from dust, and then when it deployed it, it swung itself down, dropped its legs down, and then dropped off and checked that its little blades would spin. Then, eventually after that, everyone was also very excited. Did they land another rover on Mars? Wait, what? They excited at a blue line on a white graph. Why are they excited about that? Well, if you look more closely, this graph is an altimeter graph, where, what does this say? Height. This is the height. This must be the height of the Mars helicopter. So it might be the Mars rover too. It goes at 0 or roughly 0 and then jumps up to 3 meters for, what's that, 5, 6, 7 seconds and then drops back down. It's probably not the rover jumping like that. This must be a helicopter, and this must be it flying. So this is the first confirmation back from Mars that we had a successful flight, that it took off, went up to roughly 3 meters high, and successfully landed back at the same height that it started. So this was the first confirmation of the first powered flight on another world. And this is why everyone was going bonkers and crazy at just a blue line. Eventually they got back the video and photos of this flight, which looks incredible. So here is the first flight of the Ingenuity helicopter on Mars. So this was to demonstrate that we can fly on this place, even though it has a very thin atmosphere. So here it is, spinning up the blades, taking off, and doing a little hover, a little rotate around, and then landing back on the ground. This is a film taken from the Perseverance rover. And here's it coming down. And it's working fantastic. It works as expected, hovering, doing exactly what we wanted. Here's a little bit of a takeoff again. And the landing. So you can see a little bit more closely of how it's operating. And this is an image from the helicopter looking down, and you see its shadow there as it's taking off, which is very exciting. And really, it's like what we call a Wright brothers moment. The Wright brothers were the first people for powered flight on Earth. This is kind of the first powered flight on Mars. So it's kind of a very exciting event for aviation and aeronautics and space. Now, the question you may be asking is, can I fly the Mars helicopter? Well, same thing with the Mars rovers. We probably can't do that because of the time delay between Earth and Mars. So, oh damn, we can't fly a Mars helicopter. Oh well. But what they do is they send the commands, and this is why they're waiting for this information to come back, because it does its flight, it sends the data back, and we get it the next day. What it does is it uses the images from the camera facing down to track how it's moving. So it's doing some autonomous movements so that it stably follows the commands that are sent to it. So this is, again, the downward-facing camera. It's using that to track how it moves so it can safely do its operations without someone having to fly it. This is kind of a bit more of a video to show you how that camera looks as it's flying along. And it might be tracking these rocks to see, okay, that rock's moving this way, so I must be moving in the opposite direction. And you can see this is a different flight. This is not the first flight. In this case, it's flying laterally. It's flying over a long distance to test how it can move from one location to another. And this is it landing on that flight as well. I think it's now completed about 7 or 8 flights, and it's now actually helping the rover by scouting out areas ahead of it so the rover team can plan how to drive around different types of challenging terrain. This is one of the recent shots from it. It has a color camera that it can use to look out on the environment around it, which is a beautiful high-resolution image that you have here. Actually, wait, if it can take high-resolution images of Mars, maybe we could get it to go to the recurring slope lineae to get close and take a close photo and learn more about it. That'd be fantastic because we can fly up to the cliff, whereas we can't drive up to the cliff. And that's the really exciting thing about these flying helicopter on Mars, is that can enable us to go to these very exciting regions on Mars that has a lot to teach us. And so just like we had the first little rover, if you remember right back at the start of the presentation, we then had Spirit and Opportunity that was slightly bigger. We had Curiosity, size of a car. We had Perseverance now with Ingenuity, a little helicopter. But maybe now that we can see we can fly on Mars, maybe next step is a big helicopter that could go up to these cliffs, to these recurring slope lineae, and help us to learn more about it, to see if it's water or something else. Now, okay, what if we had humans around Mars? Could we then fly a helicopter, please? Well, we could drive a rover, I think. That would be fine. We could drive that around with a joystick. That would work. We do that sometimes between people on the space station and on Earth, and that works okay. But can we do it for a helicopter? I don't think so. I'm sorry. So when we were first testing helicopters, this is a vacuum chamber which replicates the conditions on Mars. And so basically it pumps out the atmosphere and puts in CO2. And this is saying, can we thrust? Can we get lift? And yes, you see it's lifting slightly off the platform with a blade inside an atmosphere that's the same as Mars. So the first test proved, okay, we can lift off the ground. Now this is a little demo where it's the same vacuum environment, which is simulating what it's like on Mars, and a pilot trying to fly this. And as they're trying to fly this little contraption, it's bouncing all over the place. They can't control it at all, even though it's an expert pilot. And so this test was really important for them to recognize that it's really hard to fly in Mars conditions. We might get off the ground, but we can't actually make it go where we want. So they learned from that, they developed, and they came to the next stage to test out a more full-size Mars helicopter. And this time, it's not human-operated. This time, it's autonomously operated using its own control system, just like what is on the current Mars helicopter. Now, why was that important? Oh, it's making some noise for me here. That was important because the atmosphere on Mars is very thin. So just like you might be swimming in Earth, just swimming in water, when you move your arms up and down, you feel that the water slows you down. If you're kind of moving your hands or flapping your arms, you feel that the water slows you down. Now imagine you were doing the same thing in a bubble bath. The bubbles would not slow you down as much because it's mostly air. It's less dense. There's less water there. Now, that same difference is like trying to fly on Earth versus flying on Mars. On Earth, when you move, just like if you move your hands around, you can feel some air moving over your arm. That also helps when you're flying to slow yourself down when you start to oscillate. So it makes it easier to control, something called damping. But on Mars, it's much thinner, so you don't have that force to slow you down as much. And so you've got to be much quicker on your controls, and it's far too quick for humans. You've got to have the autonomous system to help you fly. And everyone's obviously very happy that there was a successful flight. It was a pretty big stage for them. So that's the current family tree of robots that are moving around on the surface of Mars. But maybe it could be a legged platform. And now I say this because this is what I work on. And I'm a roboticist that I work on these things. Why a legged platform? Well, because we explore or we see these places on Mars and on the moon that look like caves. They look like they're depressions into the soil that are lava tubes. Now, lava tubes are when lava flows and leaves a tunnel behind as the molten rock flows through. And this is really interesting for life because just like your habitats, it protects you from the elements, protects you from the radiation. There's also a nice constant temperature. And you can see these pits in different images. And what we develop and what we are testing is these robots to go and explore. This is one of the robots we're testing in lava tubes in Northern California, where they go down with our autonomy system to go and explore into these areas. Now, this is just research to develop technology that might be useful for some future mission. And as a robot goes down, it's got to navigate over rough terrain, it's got to work out where it needs to go, avoid cracks that might catch its foot. And in this case, again, it's autonomous. What does that mean? It means we're not driving it with a joystick. It means that we need to tell it what it needs to do. It needs to work that out by itself. Which direction to go? Do I go down the left passageway or the right passageway? How do I go down this large cliff without falling over? Which pathway do I take so that I safely step down? And where do I look for things that may be interesting that I want to send back information on? Oh, that's maybe an interesting color on the wall. I'm going to take some close images so I can send that back. And all these things that we can't command because it's hard to communicate in a cave because you're underground, but also because we don't know what to expect beforehand. And so it'd be very slow to do it any other way. So this is one of the technologies that NASA's working on developing, potentially for exploring some interesting places where there could be frozen water or there could be existing life in these cave environments. And so with that, I think I will pause and open up to any questions that there may be.
Wow, thank you so much, Ben. Can you see us? Are we back on your screen?
Yes.
Awesome. Well, that was a wonderful presentation, and you are an excellent storyteller. Like, I love how you're showing these pictures and images that are just fascinating. And I have a comment here that you got during the presentation from Emily. Love the energy and explanation of this talk.
Thanks,
Very
Emily.
cool and interesting. So that's just one of the many comments you have gotten. So we have a few minutes and we have some questions. Are you ready?
Let's go for it.
Okay, this is a hard one. What is your favorite part of your job?
Great question, Yahal. Honestly, the favorite part of my job is working with my team. There's brilliant people around me that are super passionate about what they do. They're very smart, intelligent. They're really cool about all the different things that they like doing outside of work as well. And getting to work with them and just like you guys have been doing in your team, getting to bounce ideas off each other, come up with cool solutions to different problems, and to do something really interesting together is very exciting. And that's probably the best part of my job, getting to work with very cool people doing fun and interesting things.
I think a lot of the students were able to experience that this week as well. So how did you get to work on robots for NASA?
Good question. Do you mind if I share my screen again, and I'll go through a little bit of that? I think I had some prepared earlier. Sorry. Okay. How did I get to where I am? So in grade 4 and 5, I loved AFL. For people not in Australia, it's a code of football that is only in Australia. I also like Lego and space and Star Wars. In high school, I liked mathematics and science, and I really liked understanding how things worked, basically, how to explain how things worked. And then going to university, I wanted to apply those tools that help to explain how things work, the science and the math, and apply that to solving problems. And that's really what engineering is using mathematics, using science to solve problems that are important to the world. I also liked windsurfing still, where I wanted to learn about how the sails work, how the fins work, so it's kind of aerodynamics, similar to what we think about or what we study for aircraft. And I still like Star Wars and space stuff. And so for that, I did aerospace engineering at the University of Sydney. Got to work on flight controllers, and then eventually on control for flying robots in the space station, and I had the great opportunity to work with someone you guys may know well, Professor Gregory Chamatov. And I really wanted to learn more about this, learn more about how we do robots in space, how we do robots in general. And so I got the great opportunity to do a PhD, which is a degree after your bachelor's, to study more, to do research on robotics. Got to play around with different ways of controlling robots. Got to be involved in something called Zero Robotics, where I was supporting high school students to write code for robots that fly around the space station. And the video here actually has them flying around with control written by high school students from Australia, where they got their code to the final of this competition, and astronauts set it up and ran their code in space, which was really cool to support that. I then had an opportunity for an internship at JPL. And then once I finished my PhD, I had the opportunity to join as a postdoc, which is a job just after your PhD, and then eventually became a robotics engineer, which I am now.
Very cool. I'm looking through my questions. You're answering them all. Thank you for sharing that, because the students, a lot of the questions were about how did you end up where you are now? And so a follow-up question, I thought this was interesting. Is it stressful carrying such responsibility in a large company?
Yeah, great question, Chloe. It can be. It can be for sure. It depends on the role that you're in. Sometimes in the company that's like JPL, which is one of the NASA centers, it's got quite a lot of history and a lot of people with a lot of experience. So often it's stressful, but you've got the support of other people in your organization. So if you need advice or if there's something you're not sure of, you can go to them to ask for help or get them to check if what you're doing is right, and you have the support of the organization around you to get it done. You still want to do really well, and there's a bit of stress there, but generally the organization is there to support you getting it done. So you've got backup, basically, which gives you more confidence to do the job.
Great. So what advice would you give to early and aspiring future robotic technologists, and how did you rise to your highest potential?
Yeah, it's a really good question. Doing what you're doing now is a great form of advice. I'd say opportunities to get involved in projects, in programs, in activities that are using STEM skills, that are helping to develop skills like programming, doing math, doing science. They're fantastic ways to learn, to grow, but really also to learn more about interesting things. So if you found this program really interesting, you want to learn more about virtual reality, diving into that and just doing some other project. If you want to learn more about space habitats, if you want to learn more about robotics, just dive into something that you're really interested in. And I think that's also how I rose to my highest potential, is taking opportunities that came to me, such as being involved in something like space teams, and really giving it my all, diving into it, giving as much as I can, because then often I found something interesting that came out of it, another activity to be involved in, another opportunity that came up. And the more I really dove into these opportunities, the more exciting they became, the more interested I became, but also the more opportunities then came from that. Now, I didn't know that was going to lead to where I am now, But by pursuing all these different opportunities, some pathways went nowhere in the end. But then one of those many pathways of just diving into things that were exciting to me eventually led to the opportunity to work at NASA. So really taking opportunities and going and giving your all to.
Perfect. Well, I think that's a great way to kind of end this, since this is the last day of this program. You took this opportunity of space teams, right? All the students that are watching. What are you going to do next? Hopefully, this inspired you and brought some new passions and interest, like we just heard from Ben, and the cool stuff you could do with robotics.
And we need more engineers.
Yes. Perfect. Yes, more engineers and scientists and technologists, all of the above. Any final thoughts for the students, Ben?
Yeah, just congratulations on taking on the challenge of space teams. I look forward to you guys pushing forward on that, and there's lots of challenges to solve for NASA. So keep pushing forward on that, and hope to see some of you over working for NASA sometime soon.
Yeah. Perfect. All right. Thank you so much, Ben. We're going to say goodbye to you. Okay, this is it. Are you ready? Are the students in the comments ready?
So ready. Do they know what time it is?
It is award ceremony time. Let's kick the show on the road. Okay, I'm going to bring it up. Okay, guys, here's what's going to happen. So we're about to get into the award ceremony portion of the International Spacecraft Exploration Challenge. And the way this is going to work is we have this really fun highlights video that's going to be a look back at what we've done these last 6 days. We have a special message from one of your teachers. He is really excited to talk to everybody. Then we have some special awards. These are both team and individual awards. And then the big finale, the Spacecraft Awards, elementary, middle, and high school divisions. Everyone that receives an award, whether it's individual or team, you might be getting something, some swag. So be on the lookout. We'll be contacting you about it. But first, we have a highlights video. So Claire, let's show the video.
We are very thankful to the people who have made this program possible, and we hope that we can do other programs with them.
My favorite part was the space preparation because I like exploring the planet and finding new things.
Noah, and I've been enjoying the Habitat Builder. I've really been able to release my creativity. It's been really fun doing this.
Deshika and Jasmine, and we're Team TGS Korea. We've had an amazing time with the International Spacecraft Exploration Challenge.
I love it, and I would definitely do it again.
Wow, what a ride, what an epic adventure this has been. And I think now we need to bring on our next guest. Claire?
Yes, so I still have chills watching that video and everything that you guys have accomplished. And with the support of your teachers, it would not be possible. So we're going to hear from one of those teachers. I'm going to bring you on. Welcome, Brad.
Hi, Natasha and Claire. How are you?
Great. How are you doing?
Yeah, good. I love the photo, I think, of me just then in this pretend spacesuit.
Here we go.
It was perfect. So please introduce yourself. Tell us a little bit about who you are.
Yeah, I'm the head of technology and innovation at the Scott School, Albury, which is on the border of New South Wales and Victoria on the Murray River. And yeah, I've got 4 kids and a wife, so family of 6. Keeps us pretty busy. And yeah, I love everything to do with science, space, technology, etc. So this is a perfect event to bring all that together.
Sounds like you're in the right place.
Yeah.
Well, can you share a little bit about what your experience has been this week?
Yeah, I think it's been fantastic just to see all the students get really involved, and particularly at my school, I've had 10 teams involved. So we had up close to 40 students, a little bit under, but close to 40 students involved, and it's just been really good to see students all the way from year 4. We've got some year 4s that were involved up to year 11. And yeah, we did want to run it at school on site, but we went into lockdown literally 4 days before it began. So that was a shame. But as my principal, Mark Gerard, said, that Scott's was the pathfinder in this space race. So we just pivoted, found a way we went online, and all the students really stepped up to the challenge, and it was really good to see.
That's wonderful. And we have so appreciated you being here. Do you have any last words of wisdom or advice, or anybody else you'd like to thank?
Yeah, I think, I mean, there's so many people I could name, and I don't want to miss anyone out. So I'll do that general, I really do want to thank, obviously, the space team, Gregory Chamatov, and One Giant Leap, and Jackie from One Giant Leap for bringing that to us. I would never have known about this if she didn't bring it to us, and helping us to get funding to help it more affordable for all our students. And so there's a lot of people to thank. And yeah, I just want to thank, obviously, all the students that just got involved.
They're excited in the comments. They're cheering you on.
and I've been in the unique situation, I think, that my son Liam, he's been involved in a team as part of my school, and my daughter Emily, she's actually with a team with Jackie's group. So I've sort of had children with foots in different camps, so to speak. But I just think it's amazing that we've had students from the United States, from Egypt, as well as all around Australia doing this all at the same time. Just learning from all these people, from having support from AWS and from Microsoft, and you guys, you've done a fantastic job, and people from JPL and NASA and et cetera, et cetera. The list goes on. It's just, been amazing. One of the best experiences in my teaching career that I've ever been involved in.
Well,
Wow.
that is so wonderful to hear. Thank you so much for being here. And obviously, you're doing an incredible job with your students because they're so excited to see you on screen. And I hope maybe you can do it again on another mission.
I will. Definitely.
Well, thank you. Thank you so much. All right, I'm going to remove you and we're going to get started on the rest of our awards.
Okay, so now it is the time for our special awards. These are both team and individual awards. So first, most of the team submitted a mission patch. So this is the award for best mission patch.
And the winner of the best mission patch is Team Dragons 1. Very cool. I love how they're sporting it on their uniforms there.
I love that picture. Okay, our next is an award based off of the spacecraft missions. This is for the most alien planet.
And the winner is Amar Saeed.
Congratulations.
Very cool.
Now the special award, again from spacecraft, for coolest ship.
And the winner is Aphrodite 1 by Team Argonauts. That is a huge ship.
Yeah, they said it was a little too big for 4 astronauts.
Slightly.
Just a little. Okay, next, a special award for biggest habitat.
The winner is Catherine Varoufis.
And the mission experts, if you remember earlier, were so impressed with this habitat. So way to go, Catherine. Okay, you got a little teaser on this winner and the special award for best team video. And there were a lot of great ones. So.
And the winner is Team Crux. Love that video. Thank you so much, guys.
Okay, so now we have some individual awards. These are some special recognition. We had not planned on having these awards when we started this program this week, but they just came out and we had to give out some extra bonus awards. So this one is for positive attitude.
And the positive attitude award goes to Olga from Team Astrofox. And Olga has been on a team all by herself. That was not on purpose. It just happened by accident. But her attitude has been so positive the whole time as she's been working with the space team support. So way to go, Olga. We love your spirit.
Our next special award, a special recognition, is an award for perseverance.
And the Perseverance Award goes to Sebastian from Team Nerds. They had some issues because Sebastian couldn't run spacecraft because of a hardware issue. So he was behind, but they were still able to catch up. So way to go for persevering.
And then we have an award for spirit. You might be able to guess who this is. And we pulled this from the comments. Someone who is the very spirited, always positive.
And very active. Award goes to
see if anybody guesses.
Maddie Moo in the comments. Love your energy.
And this is a perfect segue to the last special award for the most beloved mission expert. Any ideas on who could possibly be the most beloved mission expert? What do you guys think? I love the spelling of this hashtag.
And the winner is Dylan.
And here's some music for you, Dylan.
Wherever
so you
are.
can read all of these comments of Dylan, and I'm sure we're about to get a bunch more. But I'm just really sad that Dylan's not here.
I know, they've been asking for him. And wouldn't it be incredible if, like, all of a sudden he just came on? Dylan!
Hello.
Welcome back, Dylan, and congrats on your award as the favorite expert.
Oh, it is such an honor to be the favorite expert of this the Space Teams event. But it really was not a solo experience on my part at all. There's so many people I have to thank, mainly the spacecraft team, all of the developers we have. There's so many people worked just on the code for this. And so many people worked on just a bunch of stuff behind the scenes. I would be crazy not to thank Elise Cook. She got a total of 2 hours of sleep in the past 2 weeks. So please give her a thanks. She did so much behind the scenes for Space Teams, just an incredible amount of work, and she's fantastic. So please don't send any supports to her like saying thank you, but just please type in the comments as much as you want. She's fantastic, and she is really carrying this Space Teams. I also want to thank Chamatov and all of the other speakers because they're really kind of the heart and sharing so much knowledge in the field towards to all of us, even me. I learned a ton of things at each of the lectures, and I also sorry, just so many people I got to thank. So many people that kind of made Space Teams a reality. And most importantly, Natasha and Claire, they have done so much being the speakers and being interactive with the comments and all the students and just being great for all these webisodes.
Oh,
I'm kind of like losing my train of thought a little bit
You're getting
because
choked up. It's okay.
yeah,
It's an emotional experience.
it really is. I think I'm gonna cry. Okay.
well, okay, so Maddie wants to know, did you see my shirt?
I did. I responded to the ticket. I hope you saw that.
Check your email, Maddie.
And they're asking about how you spell your name.
So, I actually spell my name with just one I, so it's Dillon, but it's kind
But
of
because
been,
of the hashtag, you changed it just for today.
it is legally changed for today.
Well, thank you so much, Dylan, for all of your hard work and for the whole team, all of the efforts that you've put into this. And we appreciate you being the face of that and accepting this award on the behalf of your whole team.
Yes, thank you.
All right.
All right. Well, we're going to say goodbye to Dylan. I know everyone's going to be devastated. And let's get back into the last portion, which is those spacecraft mission winners. Are you ready, Claire?
Let's go.
Okay. So we have 3 divisions. We're going to start with elementary. So for elementary division spacecraft winners,
3rd place goes to Interstellar Travelers.
woohoo!
And 2nd place, Space Warriors. Well done. And now the 1st place goes to
Drum roll.
TGS Centaurus.
Woohoo!
Good job, guys.
All right, now we have the middle school division.
And the 3rd place goes to SPCC. 2nd place, Argonauts. And the 1st place winners are
Woohoo!
the Nerds.
Woohoo! Congratulations, everybody. And now we have the last division, our high school division. And as a reminder, all these winners are getting some Space Team swag, so get ready.
And the 3rd place goes to Saturn Surfers. 2nd place, Space Loopy.
I like that.
And the 1st place,
Drum roll.
Galaxy.
Awesome. Okay, but we had to have one final award, which was our overall top score across all the divisions. So this is kind of the grand winner, overall top score for the International Spacecraft Exploration Challenge.
And this top score was just a half a point away from the maximum total score possible.
Wow.
Just 1/2 of a point.
Insane.
And the
Crazy.
overall top score goes to the nerds. Well done.
Amazing. Well, congratulations, seriously, to every single student and team that participated in this challenge. I hope you learned something. I know I did, just from listening to the speakers, to the mission experts like Dylan. I mean, this has been a jam-packed week. Each of you is going to get this awesome certificate saying you completed this mission, the space team's mission. And just some final words here. It has been really this awesome adventure. Epic, unforgettable, emotional, as Dylan said. And it's just been so much fun doing this with all the students from Australia, from Egypt, from across America. And it's been great. So we would now can officially say after 6 days, you did planet builders and orbital mechanics and surface operations. Mission accomplished. All right, guys, space teams, signing off.